Welcome to this video about intervals of increase and decrease. By the end of this video, you should be able to identify the inputs where a function has a positive slope. You should also be able to identify the inputs where a function has a negative slope. You should be able to identify key characteristics given a quadratic graph and use them to help you answer questions about a quadratic equation. All right, so what is an interval of increase and decrease? So an interval of increase is all the inputs or x values where the graph is rising, meaning where the function has a positive slope. We want to know what x values are in the area of the positive slope. An interval of decrease are the inputs or x values that make the graph fall, or where the function has a negative slope. So let's take a look at number one. So I've got some falling graph, I have some rising graph, and I have some more falling graph. Okay, so I want to know what x values are in the area where there's a positive slope and which x values are in the area where there's a negative slope. So one way to do this is, because I'm talking about x values, there's really a point here. Because there's no arrow, it's not going on forever and ever and ever. I'm just going to draw a line down to the x-axis to help me see it. This is at -1. And I'm going to follow the graph, and it changes direction again here. And that x value is +1. Follow the graph, and now we're going up. We hit this point and it changes direction. It changes we're only looking at where they change in the direction, so what are the x values? And then there's no arrow, so that means we're going to stop here where x is 5. So doing this helps us see what our intervals are going to be. From -1 to +1, my graph is going down as I read it from left to right. It has a negative slope, so it's decreasing. So let's see, we're going to have this decrease. And we know the x values are between -1 and +1. But the way this gets written officially is you say -1 is less than or equal to x, which is less than or equal to 1. So what we have here is two inequalities. One when we're saying the x values are greater than -1, and one where we're saying the x values are less than -1. So when you look at it, all the x values in the decreasing section here are from -1 to +1. Okay, so it's telling you where the decrease starts and stops. So we had our decrease and it stopped at 1. Well, that's where the increase also started. So we started at 1 and it keeps increasing until here. Well, that x value is 2. So between 1 and 2, we're going to have an increase. But we're going to write our interval the same way. 1 is less than or equal to x, which is less than or equal to 2. Okay, that's where our increase is. So we stopped increasing where x is 2, and then we went on a decrease again from 2 to 5. So between 2 and 5, we had a decrease. Okay, so the proper way to write that is 2 is less than or equal to x, which is less than or equal to 5. It's the way to put our two inequalities together into one. So they're saying all the x values are more than 2, but less than 5. Okay, let's try that again with our second one here. So our second one is a little different because it has an arrow. The first one didn't have an arrow. We had end points. So really there is no stop. This is going to keep going this direction forever and ever and ever. Okay, so that means I don't have an exact x value for this left-hand side, but remember, x values going forever and ever and ever to the left are going into -infinity on the left. They'd be going into +infinity on the right. Now let's work our way across. So somewhere in -infinity we started, and we're decreasing and we're decreasing and we're decreasing until we get right here to where x is 1. At x is 1, it turns around and we start increasing until we get to x is 2. And then we start decreasing again until we get to x is 4. And then we start increasing again, and it all stops right here because there's no arrow there where x is 5. Okay, so hopefully that's going to help us see our intervals. So from negative infinity to 1, negative infinity to 1, I am decreasing. Okay, now you cannot be equal to negative infinity. So we're just going to use a less than sign, not an equal with it. Negative infinity is less than x, which is less than or equal to 1, is where we're going to decrease. At 1, we turn around and increase until we reach where x is 2. We're going to write that the same way. 1 is less than or equal to x, which is less than or equal to 2, and in that we're increasing. 2 to 4, 2 is less than or equal to x, which is less than or equal to 4. We're decreasing again. See how they're going up and down, up and down. And then at 4, we head back up again. 4 is less than or equal to x, which is less than or equal to 5, and we're going to increase there. Okay, so where one ends, the next one starts. That one ended, the next one started there. It ended here, that's where the next one started. So we're saying it goes, you're telling somebody if they couldn't see this graph, they'd get the idea, okay, it goes down, then it goes up, and then it goes down. You're giving them an idea of how it's this jagged line. All right, let's try it again on number 3. Start at the left and let's work across. There's not an arrow, so we're going to say that's a hard end right there. So at negative 2, the graph starts going down until it reaches negative 1. At negative 1, it turns around and goes back up until x is 0. Then it goes down until x is 1. Then it goes back up, and it's never going to stop going up. So the x's on that side are positive infinity. Okay, so the lines, I'm drawing the lines to help us see what x value we're talking about. And that helps us write our interval then. And the graph is decreasing. So from negative 2 is less than or equal to x, which is less than or equal to negative 1 is where it stopped decreasing. I'm just going to write D for decrease. At negative 1, we start to increase until we get to 0. So negative 1 is less than or equal to x, which is less than or equal to 0 is where we're going to increase. And then at 0, we start going back down again until we get to where x is 1. X is less than or equal to 0 is less than or equal to x, which is less than or equal to 1, and we're decreasing there. And then from 1 until the x forever for the x values, we're never going to stop increasing. I'm going to write this one over here where I have a little more room. I have 1 is less than or equal to x, which is less than infinity, meaning it's never going to stop on that side. Okay. All right, let's try an actual parabola because this is what we're going to be doing in class. We're focusing on the parabola shape. So let's look on the left. I have a arrow. Okay, my x values to the left forever and ever and ever are negative infinity. Okay, where does this graph turn around? So it's not a hard point like we had on these other graphs. It's rounded, but it always turns around at the vertex. The vertex is the very center of the graph. It's the turning point where it changes direction. So what is that x value? In this case is a positive 3. And then on this side of the graph, it's going to go forever and ever to the right. So x's forever and ever to the right are positive infinity. So doing this way, when you write on the graph, it helps you see your intervals. So I have from negative infinity, remember we can't be equal to it, or less than x, which is less than or equal to 3. And when you're looking at it and you're reading it from left to right, that's your increase. Okay, so we're going to write that as an I for increase. And then at 3, the graph is going to turn around and head back down again. So 3 is less than or equal to x, which is less than the infinity, and that's our decrease. All right, let's keep trying. Okay, so this one has a hard, you can see it. There's your turn right here. We have no arrow on this side, so we have a definite start, and we have no arrow on this side, so we have a definite stop. So let's look. On this side, we're starting at 0. We had to change at 3, and we stopped at 5. So I write these to help us see the intervals. So you know between 0 and 3, the graph is increasing. It's always less than or equal to, unless it's an infinity, x, which is less than or equal to 3. So we're increasing from here to here, and at 3, we go down. So 3 to 5 is a decrease. And so the 3 is less than or equal to x, which is less than or equal to 5. All right, so we have another curve here. The curves are a little harder to see than these hard points where you're like, yep, it definitely changed direction. So I'm just going to kind of look at it. There's no arrow on the left, so I know we're going from -1. There's no arrow on the right, so we're going to end it over here at 5. But where does the graph change direction? So we're going down, 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 down until we get to right here, and then we start going up, 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 up. Okay, so that's where x is 2. So we can see our two intervals. So -1 is less than or equal to x, which is less than or equal to 2. And 2 is less than or equal to x, which is less than or equal to 5. Now, which one's an increase and which one's a decrease? I'm going to kind of draw this line in here. So if we're just looking at this half, as we're going left to right, the graph is going down. So this is our decrease. And if we only look at this half, from here and it keeps going up, that's going to be an increase. All right, hopefully that was helpful. Let me know if you have any questions. See you in class.